The atmosphere is the thin, protective layer of gases surrounding the Earth. It is held to Earth by gravity and interacts with life, weather, and energy from the sun. Why is the atmosphere so important for Earth? First, it provides breathable gases supplying oxygen for all living things. Second, it insulates Earth and keeps a stable temperature day and night. Third, it protects us from harmful ultraviolet radiation from the sun. Let's check the main atmospheric gases and their percentages. Nitrogen 78%, oxygen 21%, argon 0.93%, carbon dioxide 0.04%. Other trace gases, about 0.03%. The atmosphere is divided by vertical temperature profile. Temperature change with altitude is the only key criterion. Earth's atmosphere has 5 layers from 0 to 10,000 km. Troposphere, stratosphere, mesosphere, thermosphere and exosphere. With temperatures rising and falling alternately with altitude. Welcome to the troposphere, the lowest and most important layer of Earth's atmosphere. After learning the basic structure of the atmosphere, we will now focus on this critical layer where all our daily weather occurs. This layer directly supports life and shapes our living environment, so let's explore its key features together. First, let's look at the basic properties and global distribution of the troposphere. It is the lowest atmospheric layer, containing approximately 75% of the total atmospheric gases and nearly all atmospheric water vapor. Most importantly, all daily weather phenomena, including clouds, rain, wind, and storms, take place in this layer, making it the layer we interact with most directly. Next, we introduce 2 critical parameters and local observation methods. The environmental lapse rate in the troposphere is approximately 6.5 degrees Celsius per kilometer. In Hong Kong, the Kings Park Radiosonde Station conducts long-term monitoring. It releases radiosondes twice daily to measure temperature, pressure, humidity, and wind profiles, providing accurate real-time atmospheric data for Hong Kong. Now let's learn about the stratosphere together. The stratosphere is Earth's second atmospheric layer, ranging 12 to 50 kilometers above the surface. Separated from the troposphere by the tropopause. This layer contains the critical ozone layer, which absorbs harmful ultraviolet radiation from the sun, acting as a vital shield for all life on Earth. Temperature rises with altitude here, and stratospheric circulation drives the polar vortex, directly influencing extreme weather patterns on the ground. Commercial jets cruise in the lower stratosphere to avoid turbulent weather, making this layer vital for global aviation.
Welcome to the mesosphere, the guardian layer stretching from 50 to 90 kilometers above us. This is where most meteors meet their end. Friction with air molecules ignites these cosmic visitors, creating the shooting stars we wish upon. At the edge of space, watch the ethereal noctilucent clouds. These are the highest clouds, made of ice crystals glowing under the summer sunset. Too high for balloons, too low for satellites. Only sounding rockets dare to venture here, collecting data to unravel the secrets of our planet's coldest frontier. The thermosphere stretches from 80 to 500 kilometers above Earth. It absorbs solar radiation, and reaching 1,500 degrees Celsius. But you wouldn't feel the heat as the air is too thin there. Auroras happen here because solar particles will hit the gas molecules. Oxygen glows green and red while nitrogen glows blue and purple. The ISS orbits here at 400 kilometers, right inside the thermosphere. Atmospheric drag slowly pulls the satellites down, and they'll burn up without boosts. Above that, the exosphere extends to 10,000 kilometers. Particles here escape Earth's gravity, as the exosphere have no clear boundary.
Above 60 kilometers lies the ionosphere. Not a separate layer, but an electrified region overlapping the mesosphere, thermosphere, and exosphere. Solar extreme UV creates free electrons that reflect HF radio waves, enabling global communication. But for GPS satellites, these same electrons slow signals, creating positioning errors. Today we've journeyed through all 5 atmospheric layers, from the weather-filled troposphere, through the protective stratosphere, the cold mesosphere, the hot thermosphere, to the fading exosphere. Each layer plays a unique role in making Earth habitable. Thank you for joining us on this vertical journey through our planet's gaseous envelope.